Welcome to Money and Markets, Series 1, Lesson 3. This episode is called Inflation is Stealing Your Money. And I mean the title literally. Here is the setup. You save $1,000 in a bank for 3 months and earn $5 in interest. You celebrate by buying a Big Mac. But during those same 3 months, the price of everything you buy went up. So the question is not whether your balance grew. It did. The question is whether your balance grew faster than prices did. If it did not, you lost purchasing power even while the screen showed a bigger number. That tension between the rate the bank prints on a poster and the rate that actually matters for your life is what this episode teaches you to measure. We will build one formula, walk it through real numbers, and use a burger to map what it means across the world. 3 definitions before we touch any formula. Learn these, and the rest of the episode becomes algebra you can check on a napkin. First, the nominal interest rate. This is the actual rate the bank advertises. The number on the poster. The number on your statement. If the bank says 3%, 3% is the nominal rate. No adjustments. No fine print about prices. Second, the inflation rate. This is the rate at which prices increase. When groceries cost more this year than last year, that rise is inflation. Some people call it a thief, because inflation is a drop in the purchasing power of money. Your dollars still exist. They just buy less. Third, the real interest rate. This is the inflation-adjusted return. What you actually keep in purchasing power after prices move. It is the number that tells you whether saving made you richer or just kept the screen looking polite. Now we build the formula, the Fisher approximation. Watch the screen as each piece appears. Real rate approximately equals the nominal rate minus expected inflation. In symbols, our real is roughly our nominal minus pi expected. The Greek letter pi with a little e stands for the inflation rate you expect over the holding period. This is a subtraction, the simplest operation you learned in elementary school. If the bank pays you 6% and you expect inflation of 4%, your real return is roughly 2%. 6 minus 4 equals 2. That is the Fisher equation in its approximate form. An exact version of this formula exists. It uses multiplication instead of subtraction, and the difference matters when rates are large. But for the rates most people see on savings accounts and mortgages, the subtraction is close enough to build correct intuition. We will use it for every example in this episode. Let us plug in the numbers. 2 examples side by side so the pattern sticks. Example 1. Your bank pays a nominal rate of 3% per year. Inflation over the same period is 2%. Apply Fisher. 3 minus 2 equals roughly 1% real. Your purchasing power grew, but barely. 1% real means your savings can buy about 1% more stuff at the end of the year than at the start. Example 2. Same bank, but now the nominal rate drops to 2%, and inflation stays at 2%. Apply Fisher. 2 minus 2 equals 0. Your balance went up on screen, but your purchasing power did not change at all. You treaded water for an entire year. The headline matters. A higher nominal rate does not automatically mean you are better off. You always have to ask what inflation is doing alongside it. Now, the painful case. The thief in action. Suppose inflation jumps to 5%, but your savings account still pays only 3% nominal. Apply Fisher. 3 minus 5 equals negative 2%. Negative. Your balance grew on paper, but prices grew faster. At the end of the year, you can buy less than when you started, even though the bank printed a positive number on your statement. This is what it means when we say inflation is a thief. It does not take dollars out of your account. It shrinks what each dollar can buy. And when the real rate is negative, all else equal, delaying consumption loses real wealth. Your savings are shrinking in purchasing power, even as the balance grows on paper. Watch the dollar on screen shrink. That shrinking is not a metaphor. It is arithmetic. 3 minus 5 is negative 2, and negative 2% is a real loss of purchasing power. Now we travel the world with a burger. The Big Mac Index was invented by the Economist magazine in 1986 as a lighthearted guide to whether currencies are at their correct level. The idea uses purchasing power parity. That is the notion that exchange rates should eventually move toward the rate that makes an identical product cost the same in any two countries. Here is the worked example. A Big Mac costs £5.29 in Britain and $6.12 in the United States. Divide the British price by the American price, and you get an implied exchange rate of 0.86. But the actual market rate at the time was 0.75. The gap suggests the pound is about 15.7% overvalued against the dollar on this measure. The Economist calls this burgernomics, and openly says it was never meant as a precise gauge of currency misalignment, just a tool to make exchange rate theory more digestible. That humility is exactly why it works as a teaching anchor. Look at the country cards on screen. Same burger, wildly different dollar equivalent prices. Switzerland sits about 48% above the US base, the most expensive Big Mac in the dataset. Norway is about 23% above. Meanwhile, other countries price the same burger well below the American benchmark. What does this tell you? Not which currency to trade on Monday morning. The data is explicit about that. It tells you that the same nominal amount of money stretches very differently depending on where you stand. $1 in Zurich and $1 in Mumbai are the same piece of paper, but radically different purchasing experiences. This connects directly to Fisher. Inflation is the domestic version of the same idea. Same currency, different year, different purchasing power. The Big Mac map shows the gap across countries at one moment in time. The Fisher equation shows the gap across years in one country. Both are asking, what can your money actually buy? Let us zoom out to decades. $1 in 1974, the year Bankhaus-Herstatt collapsed and changed banking regulation forever. A story we will tell in a later lesson. That $1 would need roughly $6.40 today to buy the same basket of goods. Groceries, rent, tuition, all repriced upward, while the denomination on the bill stayed the same. Here is a shortcut for your intuition. The rule of 72. Divide 72 by the annual inflation rate, and you get approximately how many years it takes for prices to double. At 2% inflation, prices double in about 36 years. At 3%, about 24 years. At 5%, only about 14 and a half years. That last number means a teenager alive today could see prices double before making a single mortgage payment. Inflation is not an abstraction. It is the clock running against every nominal promise in your financial life. Every fixed salary, every savings account, every bond coupon that does not adjust. So what can you actually do? Here is a household-level framework. Not investment advice, but vocabulary so you can read the menu. First, match your horizon to your instrument. Short-term goals want liquidity, even if the nominal yield is modest, because you need the money soon and cannot ride out a price drop. Long-term goals force you to think about real exposure. Will this instrument keep pace with prices over decades? Or will inflation quietly erode it? Second, know that inflation-indexed instruments exist. In the United States, TIPS, Treasury Inflation-Protected Securities, adjust their principal with the Consumer Price Index. If prices rise 3%, your principal rises 3%, and the next coupon is computed on the bigger base. IBonds work similarly with different purchase limits and tax timing. Same government issuer. Same credit quality. Different inflation bet. Third, diversify globally. Different countries experience different inflation. Your real outcome depends on where prices move, not just where your broker is headquartered. 3 takeaways to carry forward. 1. Always subtract a serious inflation story from any nominal rate before deciding whether saving is making you richer. The Fisher approximation. Real roughly equals nominal minus expected inflation. That is the one-line version of that discipline. 2. Purchasing power comparisons like the Big Mac Index illustrate the geography of prices. They are a teaching map, not a full foreign exchange model. But the intuition they build about what money can buy is permanent. 3. Inflation shocks redistribute wealth between nominal borrowers and nominal lenders in predictable directions. If you owe a fixed payment and prices rise, inflation helps you. If you are owed a fixed payment and prices rise, inflation hurts you. Once you see the cash flows, the direction is arithmetic, not mystery. Next lesson, we tackle the grammar of the yield curve, spot rates, forward rates, and discount factors. I will see you in lesson 4.